Okay, so I'm recording ready. Okay, I'm recording. So you can see my screen, Okay, yeah, recording. Now, okay, we go to potential divider. Okay, after that, we will discuss about potentiometer, right? So that's our objective for today. So we will explain what's the principle of potential divider and use the equation, potential divider. Okay. So, what based actually potentiometer is based on principle of potential divider. That means it divide the voltage. Divide the voltage. Last time you learned about this series circuit. The where is it? The series circuit, right? Resistor in series. So you have three resistor in series. It divide the voltage accordingly. Yeah, like resistor 1 has voltage 1, resistor 2 has voltage 2, resistor 3 has voltage 3. If resistor, let's say resistor 2 is a bigger resistor, then it has a bigger voltage. The total voltage is total all the voltage V1 plus V2 plus V3. So I can say the three resistor, they divide the voltage into V1, V2, and V3. They divide the voltage, yeah, from the total voltage, divide into V1, V2, V3, according to the resistor 1, resistor 2, resistor 3. So this is what I call potential divider lah. If a resistor in parallel, it does not divide the voltage, because all of them have the same voltage. You see that? All of them have the same voltage. But if you have resistor in series, it divide the voltage into V1, V2, V3. They have different voltage. Yeah, bigger resistor will have bigger voltage. Okay, so that's the actually what we learned before actually. Yeah. So this you see, two resistor in series, they divide the voltage. So a potential divider produces an output voltage. Okay, am I recording? Yeah, I'm recording now. Excuse me. Recording. Good. So produces an output voltage that is a fraction of the supply voltage. Okay. Yeah, it produces an output voltage a fraction of the supply voltage because it already divide the supply voltage into smaller fraction, into V1 and V2. So this V1 and V2, they are smaller fraction of the total voltage, of the supply voltage. So this is done by connecting two resistors in series or uniform homogeneous wire. So yeah, I actually put over here already. See. So you can see these are two resistors in series. You can use two resistors in series, or you just use a potentiometer. You see, this is a meter wire. So we can also, yeah, instead of using two resistor, we can just use a long wire with resistor. Okay, so it divide the voltage into V1 and V2. Hold on a second. Got, got disturbance. Yeah. Yeah. So yeah. So resistor 1 will have voltage 1, resistor 2 will have voltage 2. Like you see, you can get this formula. Yeah. V1 equal to R1 over R1 plus R2 over V. V2 will be R2 over R1 plus R2 over V. Over this V is the total voltage. How do you get this formula, class? Actually, it's from Ohm's law. Let me show you. Okay. So from here you can see, yeah, V total is equal to I total R total, and we know that R total is R1 plus R2 because two resistors in series. So it is R1 plus R2. Okay. And then what else I can say? Okay. So and then furthermore I can say V1. Let's say V1 is I1 R1. Correct or not, class? V1 equal to I1 R1. I have two formula. Yeah, we have the first formula and then the second formula. I can just use, 2/1. Yeah, 2/1. So I get, what do I get? So I get V1 over V total. See that? See the previous formula, this one. Let's put it over here. Okay. Okay, over here. Okay. So V1 over V total. So what do I have? V1 over V total. So I get I1 R1. Below here is I total R1 plus R2. So can you see that? I can cut off. And then they all, because this is a series circuit, so the current is the same. Current total equal to I1 equal to I2. Because series circuit, they have the same current. Remember we learned about series circuit? Where is it? If series circuit, the current is the same. See that? The current is the same. So let's go back. So the current is the same for, because only one circuit, so the current passes through all the resistor. So the current is the same. So I can just, when I divide, I cancel off the current because they have the same current. And then what else? This one, we cross multiply, go to over here. So in the end, what do I get, class? So I get V1 equal to R1 over R1 plus R2 V total. So that's how I get this formula. Understand? Yeah. In fact, actually this part actually is actually R total. Yeah. The below here is actually R total. Okay. This part is R total. R1 plus R2 is actually R total. Okay, what I want to say is, the higher the resistor over here, then the higher this voltage. If this resistor 2 is lower, then it will have less voltage. This is what we call potential divider. Potential divider. For example, I can say, let's say I have 10 volt over here, 10 volt. Okay. Now, let's say this resistor one is only 3 ohm. 3 ohm. And then resistor 2 is 7 ohm. Let's say lah, yeah. Resistor 1 is 3 ohm. Resistor 2 is 7 ohm. So what will be this voltage? This voltage will be divide accordingly. I should put this as 7. I should put this as 7, a higher resistor. Resistor 2 is smaller, so it's 3 ohm. Sorry, yeah. So voltage 1 will also get higher voltage. Resistor 1 will get higher voltage, 7 volt. And then resistor 2 will be 3 volt. Okay. Or for example, let's say not necessarily have to be, it can be, let's say this is 1 ohm. 1 ohm. Okay, 1 ohm. And this is a 4 ohm. What do you think, class? What do you think will be the voltage 1? What do you think will be voltage 1? Yeah, let's say this is a smaller resistor, so this will be smaller voltage. So this one higher resistor will get higher voltage. Let's calculate. Let's calculate and see, because when smaller resistor, smaller voltage. Bigger resistor, we have bigger voltage. It potential divider, it divide the voltage. Okay, let's calculate and see. So V1 will be equal to 1 over 1 plus 4. Isn't it? The total resistance is 5 ohm. Okay, so it's only one part of it. Resistor 1 is only one part of it. So over the total voltage, 10 volt. So I get what? 1 over 5, 10. So what do I get? Yeah, this one is only, this one is 2. So it's 2 volt. Okay. So I can say V1 will get 2 volt. 2 volt. What about V2? V2 will get, of course, it will get 8 volt. Because 2 plus 8 equal to 10. Yeah, 2 plus 8 equal to 10. 10 volt. See, if one part of it is get 2 volt, if 4 ohm, 4 part of the 5 ohm, you get 8 volt. So bigger resistor, bigger voltage, smaller resistor, smaller voltage. Same thing go to if you have a resistant wire, this is what we call a resistor wire. Yeah, wire with resistor. Yeah, this whole wire is a resistor wire. That means it has resistor lah. It has resistor, yeah, plus. So let's say longer length we have higher voltage. Yeah, if longer length we have higher voltage. Let's say longer length, higher voltage, shorter length, smaller voltage. Because we know this thing. Resistor is proportional to the length, proportional to the voltage. That means the longer the length, the higher the resistance, the higher the resistance, the higher the voltage. Why we say the longer the length, the higher the resistance? Because we learned before. We learned before very, very early in the part about this formula. R equal to rho L over A. Remember that? R equal to rho L over A. Because R equal to rho L over A. So we can say the longer the length, the higher the resistance. Understand? The longer the length, the higher the resistance. And then further on, we have Ohm's law, V equal to IR. V equal to IR. So the bigger the resistance, it take up a bigger voltage. The longer the length, the higher the resistance. The higher the resistance, it take up more voltage. Understand, class? Good. So same thing like, for example, I have here I have 10 volt. Let's say I have 10 volt, and this one is, let's say 1 C. Okay, let's say this is let me think. What will be suitable? Let's say this is 1 cm, and this is 4 cm. L1 is 1 cm, L2 is 4 cm. What do you think will be V1? Will be same case as this one. If 1 cm, 1 out of 5, 1 plus 4 is 5. 1 out of 5, you get 2 volt. This one get 2 volt. Then this one will be V2 will getting 8 volt. Yeah, longer length. Yeah. So I make it opposite already. Yeah. So I can say the longer the length, the higher the voltage. The shorter the length, the smaller the voltage. Okay, class? Understand? Give me a thumbs up if you understand, class. Understand, very good. Yeah. Okay, let's continue. Let's continue. Okay, let's continue. This is called potential divider lah. Yeah, it is derived from just Ohm's law. Just Ohm's law. V equal to IR. I come from this formula, V equal to IR. This potential divider formula. So now we go to potentiometer. Yeah. Now we go to potentiometer. It is actually based on the thing we discussed before, the resistant wire. So also based on this, resistant. Let me. So it also based on that thing. So the longer the length, the higher the resistance, the higher the resistance, the higher the voltage. Based on this one, potential divider also. Yeah. Potential divider, the longer the length, the higher the voltage. Okay, so potentiometer is actually based on potential divider principle. Okay, so before we discuss this, actually all of this we learned before. Yeah, let us look back to our notes. Yeah, our notes. Yeah, so potentiometer. Yeah, is everyone already come in? Why only 648? 40, actually only 46 students. Yeah, they are missing of 20 students. Yeah, 20 students. Wow, sleeping? Are they sleeping? 20 students still sleeping. So sad. So sad. They are not. I yesterday watch a movie. A drama lah. Yeah, a child so eager to learn. Uh, at home don't have food to eat. No chicken, no meat. Just vegetables. But she's so hardworking. Even have to walk long distance, go to school, get number one in the class. Because of very poor background, he really make the effort to come to school to learn. Yeah, yeah. Even she secretly people he don't have the good opportunity to learn, but he see other children they learn. He secretly learn behind them. Yeah, yeah. He very initiative. No people force her to learn, but she learn by her own initiative. See, we lack of this kind of this virtue. This kind of student are very hard to find. Very hard to find. Yeah. No people force, no people tell you what to do, but she know learning is very important. Yeah, getting knowledge is very important. She make an effort to learn. Yeah, yeah. If I have this child, I feel very proud. I feel I very sayang. But sadly now this kind of students no cannot find anymore because why? Uh, family background now is not so poor anymore. They don't have to fight for their life. They don't have to, everything go easy already. Now have iPad and everything. Yeah, so very hard to find this kind of student anymore. Yeah, so I hope that don't get used to this kind of easy life lah. We have to fight for living. Yeah, you go to the poor village. You see the child. They are very eager to learn actually. Yeah, don't get spoiled. Don't get spoiled by all kind of technology, everything. Yeah. So, all right. So potentiometer, the working of potentiometer is based on the fact that the fall of potential across any portion of the wire is directly proportional to the length of wire provided wire has uniform cross-sectional area and constant current flowing through it. The potentiometer is balanced when the jockey, the sliding contact, is at such a position on wire AB that there is no current through the galvanometer. Okay, so yeah, so the important point is over here, the blue, the green line. You see that the working of potentiometer is based on what? Yeah, potential across any portion of the wire. Potential across any portion of the wire is directly proportional to the length of wire. That means it's the same case as this one. He said potential means the voltage. The voltage across any part of the wire directly proportional to the length. That's what I mean. That's what I mean. So the voltage of any part of the wire is proportional to the length. The longer the length, the higher the voltage. The shorter the length, the smaller the voltage. That is what it means. See? Voltage across any part of the wire is directly proportional to the length. So the shorter the length, the smaller the potential. The longer the length, the higher the voltage, the higher the potential. But the wire must have uniform cross-sectional area and constant current. That's why I say when you do the experiment of potentiometer, you cannot slide the jockey along the wire. Don't slide the jockey along the wire because you make some part of the wire to have smaller cross-sectional area. Then the wire become non-uniform. If non-uniform, then I can say the potentiometer got error lah, not accurate anymore, not accurate. Okay, so this wire must be uniform area, uniform cross-sectional area, the whole wire. Non-uniform, if non-uniform means something like this. We want uniform wire like this, yeah. Even I draw actually non-uniform also lah. Yeah. Non-uniform, if you got slide, that becomes something like this, yeah. Something like this, yeah. Some parts thin, some part like that. Yeah, this non-uniform lah. If you slide the wire, non-uniform area, then you can say the resistance is not constant along the wire. Yeah, the ratio is not the same. Okay, so continue. The potentiometer is balanced when the jockey is at such a position on wire AB when there is no current through the galvanometer. So I can say the potentiometer is balanced. Balance means I can say balance. When no current means balance. When no current through the galvanometer, then it's balanced. Still remember, you do the experiment of potentiometer. You put the jockey until you can find a position where the needle shows zero reading. The needle show zero reading. Then that is the balance length. Yeah, you get L0 first. L0 balance length when current equal to zero. You also, after that, you close the circuit like this one. You close the switch. Then you get L, isn't it? And then you change the resistor, external resistor. You got 6 resistor in parallel. You change it, the resistor, and then you get a different L already, isn't it? That's the experiment we done. So we always find the we always find the galvanometer to get zero current. We always make sure that this galvanometer shows zero reading. Then I can say this part, this LAC is balanced. As balanced when the galvanometer reading shows zero current. Balance. Okay, what is mean by balance? Yeah, what is mean by balance? I will explain about this class. Don't worry. Okay, let me explain. Yeah. So class like this, like this. Yeah. So let me explain it this way. So you can see all this wire has resistance. All this wire has resistance. So for example, let's say I have let's say this resistor this voltage is let's say what is it? Maybe it's, let's say, 10 volt. Just put as 10 volt. Okay. Put blue color. Okay. So it's like this. Yeah. This positive. This negative. So I can say over the negative side is all 0 volt. 0 volt. So at B here is 0 volt. Okay. At B here is 0 volt, and then at positive side is 10 volt. 10 volt, yeah. At the point A, is 10 volt. At point B is 0 volt. Okay, class. And then here we have an unknown voltage. This unknown battery must put like this, positive, negative also. See that here is positive, here is negative. So it must be like this also. Must be like this also. Okay. So let's say class, this okay. You see AB is a longer wire, isn't it? A to B is a long wire. AC is a short wire, right? AC is a short wire. AB is a long wire. So if AB is a long wire, then it must have a bigger voltage. AC is a shorter wire, so it must be a smaller voltage. Yeah, based on the potential divider. Longer the longer length, more voltage. Shorter length, small voltage. Okay, so if you see the battery above is 10 volt, it has a longer length. Longer length. So let's say the whole length, let's say is 100 cm. The whole length is 100 cm. So let's say AC is only 40 cm. 40 cm. So longer length, bigger voltage. AC is a shorter length. So this battery, the battery below, must be a smaller battery. It cannot be a bigger battery than the above. Okay? Class, understand? So the above one must be a big battery. The below must always be a small battery. Because why a small battery? Because it has a shorter length. If below is a bigger battery and then the top is a smaller battery, then you won't get balance. You won't the current won't be zero. The current will not be zero. It's not balanced. Not balanced. You want balance, the below one must be a small battery. Below must be a small battery. The top one must be a big battery. Because why? Because the top one is for a longer length. The below one is a shorter length. Shorter length, smaller battery. So like this one, if 10 volt is for 100 cm, then 40 cm should be for how many volt? What do you think, class? What do you think? It must be 4 volt. Understand? If 100 cm is for 10 volt, then below is for 40 cm is for 4 volt. Understand, class? Understand? Yeah. Okay, good. If you forward and then you place the jockey at 40 cm, of course you will get balance. Yeah, you get current equal to 0 ampere, and then then this wire is balanced. LAC is balanced. Okay, plus it's like this. Something like this. So if I want to show you, something. Just now I say this is 10 volt battery. So here at the right hand side is 0 volt, at the left hand side is 10 volt. So what happened over here, class? So why is it the current here equal to 0? Why is it current equal to 0? So maybe let me draw again, like, yeah, bigger, yeah? Because if small cannot see, I make it bigger. So this is the resistant wire. Okay, so this is a small battery. Okay, a galvanometer. Okay, a galvanometer. Put the jockey over here. So let's say this battery, the top battery E1 is 10 volt. So what happened? Yeah, somebody coming in. Yeah, just come in. You just wake up, class. So and then okay, class. So it's actually the working principle is like this. Yeah, let's say below E2 is let's say E2 is 4 volt. Let's say lah, yeah, 4 volt. Okay, like this, class. Look carefully, So negative terminal here is 0 volt lah, and then the positive terminal here will be 10 volt. So all along here is all 10 volt, 10 volt. Yeah, I should put this point as B, A, and then B, and then this part is C, class. Okay, and then all along here is all 0 volt. Now, I get a balance at I get balance at 40 cm. The whole wire is 100 cm. Yeah, the whole wire is 100 cm. Okay, and then A to C is only 40 cm because 4 volt. Okay, and then you get current 0. Current 0. So I can say this 40 cm is balanced. Why like this, class? Why no current? Why no current? It's because like this, class. You see, why is it positive with positive here? Why the terminal is positive here and here also positive? Yeah, if you look at the EMF direction, is that this way. This one is opposite. E2 considered to be opposite to E1, you know, it's opposite to E1. So you look, class. So this is all a resistant wire, yeah. This whole thing is actually a resistant wire. This whole thing is actually resistant wire. So across the resistant wire, the potential actually dropping. It's actually dropping from 10 and then become 9 volt, 8 volt, 7 volt, 6 volt. At point C is 6 volt. At point C is 6 volt, dropping. This one's battery supply voltage. This resistor use up voltage. From 10, 9, 8, 7, 6, and then 5, 4, 3, 2, 1, and 0. Yeah. So it's like 10, yeah. Yeah, let me write again. So become 5, 4, 3, 2, 1. Finally, 0. At point B is 0. So across the whole resistor, the potential is dropping until point C is 6 volt. It dropped from 10 volt, dropped to 6 volt. And then for below here, this part is all 10 volt. Yeah. This whole part is 10 volt. Here no resistor. But you see, this battery is opposite direction. Go from positive down to negative. So it's like potential drop, or can say potential cancel. Yeah. Last time is going up the stair. This one is like going down the stair. From positive go to negative. So from positive go to negative, the 10 volt drop to 6 volt. So across, at the negative terminal, it becomes 6 volt. Understand? Because the battery here is 4 volt. 4 volt, then it minus the 4 volt. Yeah, I can say, the voltage across here is 4 volt. Understand? Voltage across is 4 volt. 10 minus 6, you get 4. So it's like cancel from high potential positive go to negative low potential. So it's like 10 minus 4, you get 6. So it dropped to 6 volt. So you see, at the resistor wire, if from 10 volt drop gradually from 9 to 8 to 7 until 6. So here drop 6, here drop, I can say here A to C, he dropped 4 volt. Yeah, A to C, he dropped 4 volt. And then across the battery below here, it cancel 4 volt also. So it turned up here, negative terminal here is 6 volt. The point C here also 6 volt. 6 volt, 6 volt. So no current because same potential. Same potential. So when same potential, no current lah. Understand? Understand, class? And same potential, current only flow from, how do current flow? Current flow from, always flow from high potential, go to low potential. Current flow. Current flow. Why we say current flow from high potential to low potential? Because that's the how it works. It's like a battery, positive, negative. Resistor. Okay, class. Let's say this battery is 10 volt battery. Okay, why when you why in this circuit you have current flow? Because current you always say current flow from positive go to negative, right? Current always flow from positive go to negative. Why? Because the positive terminal is considered high potential. And then the negative terminal is considered low potential. That's why got current flow. Got current flow in this circuit, current always flow from positive to negative. Why you always say current always flow from positive to negative? Because positive terminal has high potential. Negative terminal has low potential. That's why got different in potential. Or we can say this way. If this battery is 10 volt, that means that the negative terminal is 0 volt. The positive terminal is 10 volt. Can you see the difference in the potential? This one is 0 volt only. This one is 10 volt. That's why positive terminal is 10 volt high potential. Negative terminal is 0 volt low potential. So current always flow from high to low potential. That's why this circuit got current. Let's say if you have a capacitor, let's say capacitor, uncharged capacitor, got current flow, class? Got current flow if capacitor uncharged. Yeah, that means if uncharged, that means no positive negative. Yeah, uncharged. If uncharged, that means the same potential. Yeah, I can say potential. If same potential go to same potential, no current. No current. Yeah. So if uncharged means no high, no low, no high, no low potential. So that's why the current is 0. So current only flow when you have different in potential. Yeah, it's like water flow from, water. Why water can flow? Because water flow from high, go to low. If can flow. If same height cannot flow, the water can flow. Yeah, the water can flow down. The water because got different in height, got different in potential. If can flow to here. If you have same height, can the water flow? Plus, if let's say you have the same height like this, if already same height, yeah, same height like this, can the water still flow? Current is 0, right? The water same height already, the water cannot flow. If you have different in height, then different in potential, the water can flow. The water can flow. Understand? So same thing lah. Uncharged capacitor, no current. So this is the same thing as this one. Like here, the potential drop from 10 to 6. Here across the battery, the potential cancel from 10 to 6. So 6 volt, 6 volt. No, same. They have become same potential. Same potential. That's why 0 current. No current. Yeah, the gamma meter gets 0 reading. Now you understand, class? You understand, class? Yeah, tell me if you understand. Good, good. Now, okay, so that's quite an explanation. Now go back to here. Yeah, go back to here. So I just want to wrap off all this. Okay, so that's the basic. That's the basic. Okay, that's the basic. Now, so EMF. Look at the equation. EMF is voltage across. EMF is voltage across AB. And then EX is voltage across AC. Okay. So here must have another battery lah. So voltage across AB is EMF. Voltage across AC is EX. So I can say LAC, the length AC is for voltage AC. LAB is for voltage AB. I can further write this one. Let me write properly. So VAC is EX. VAB is what? EMF. So below here is EX. Okay. Above here is E. So I can say LAC over LAB is equal to EX over E. Understand? That's what I say just now. That's what I say just now. When this is 10 volt, yeah, and the whole wire is 100 cm, and then LAC is only 40 cm. What do you think is EX? EX will be 4 volt. Because it's based on this formula. Okay, based on this formula. So LAC is 40 cm over LAB is 100 cm. The ratio is the same. EX is 4 volt over the EMF above is 10 volt. So it's for the length is 40 over 100. For the EMF is 4 over 10. It's the same ratio. Understand? Understand, class? Understand? Good, huh? Okay, good. Now go on to the next one. Now this one, okay, let me. I have to all this thing. I have to put somewhere else. Okay, now this part, yeah, very fast only, yeah, very fast. Now this one just now you don't have any. Okay, these are the these are the here you can see here are the this is akan keluar dalam apa dalam UPS lah, UPS the objective question. What is the function of potentiometer? Potentiometer is to measure unknown EMF. Let's say you have unknown EMF. So by looking at the ratio of the length 40 over 100 cm, you can estimate, you can determine the EMF of this unknown voltage. Can determine unknown voltage. So if let's say you have a battery, you don't know what voltage, you can use potentiometer. Looking at the length, you can know what kind of what voltage is the battery. What voltage is the battery? Use this equation only. LAC over LAB equal to EX over E. Then you can know what is EX. You can determine what is EX. Oh, so from here I determine EX is forward when it shows balance length 40 cm. Understand? You can also measure the unknown EMF with external resistor. You can compare two EMF also. Can compare two EMF. Like this one you see. You can make it like this. Like let's say E1 has length 1, E2 has length 2. So which one is a bigger battery? Of course, E2. E2 is a bigger battery because it has longer length. E1 is a smaller voltage, so it has a shorter length. So you can compare to battery, the function of potentiometer. So like E1, see L1 small, E1 small. L2 is longer, AD longer, so it has bigger EMF. So you can compare to EMF. You also can measure like your experiment. You can measure the internal resistance of battery also. Yeah, you can even find the internal resistance. So internal resistance is the small r. Just now the unknown EMF is E, or EX lah. So you can find EMF, you can find internal resistance, you can compare to EMF. So potentiometer, you can find the EMF or internal resistance of an unknown battery. Unknown battery. That's the function of potentiometer. Understand, class? Good, yeah. So, okay, going back to this one, I hope just another 5 minutes, please. Just another 5 minutes. So, look at this one. You see, look at this one. Okay, just now you don't have resistor, right? If you have resistor, what happened, class? You have resistor, what happened? Then VAB, yeah, last time VAB is totally EMF only. But now if you have a resistor, then it become what? If let's say this battery has internal resistance, then VAB will be equal to E minus IR. E minus IR. Because it's like this, class. This you must remember, this wire above is like a resistor also. Understand? No. It's like a complete circuit. So it's like, this wire, it also has resistance. So I can say like this. This EMF is equal to IR plus, this resistor R is actually in series with AB. In series, they're series. So they're actually IR plus IRAB. This the current here got current flow. Current flow throughout this whole circuit here. So this AB also another resistor. So let's say, so I can say like this lah. So I can say like this. So E minus IR will be equal to what? This IRAB is what? Voltage AB. Understand? VAB, VAB is VAB is E minus IR. Understand, class? Understand? Okay, good. Good. Okay. If you don't understand, you can look back at the video later, YouTube, my video. So VAB, and then EX, and then what about this part? Yeah, this is VAC. Yeah. Just now the whole wire here is VAB lah. Just now here is VAB. Okay. VAB is E minus IR. Okay. And then VAC is the EX over here, EX. VAC is EX. So I can same lah, goes back to this one. LAC over LAB equal to VAC over VAB. So that means I can put it this way. VAC is EX, and then VAB is E minus IR. Okay, that's it. The last one, this one, yeah. 2 more minutes only, yeah. Very simple. This one we learned before. Okay. You remember, you open the switch and you close the switch. You open the switch, then there'll be, I can say, if you open the switch, I need to remember what you learned before in your notes, yeah. You learn about terminal voltage. That's what I always say about this one, terminal voltage. If you open the switch, then the VAB equal to EMF. If you open the switch, then the I think I need to screenshot this one. Put it there, right? Put it here. Yeah. You learned about this before. This terminal voltage. Remember? If you open the switch, then below here there is no current. Below here, okay. If you open the switch, then the current is 0 here. The current, there is no current. So the IR kecil is also equal to 0. Yeah. When you open the switch, the voltage AB is EMF E. Okay. So when you open the switch, and then so the VAC is equal to EMF. Yeah. See this one? When you open the switch, the VAC is VAC. That means the VAC is equal to E1 only, EMF, because minus IR is equal to, because no current, so IR equal to 0. So VAB equal to EMF. You get so VAC is equal to the EMF E1 only. VAC is E1 only. Okay, but if it's closed, what happens if you close? If you close the switch here, what happened? Then here got current flow. Then here got current flow. Yeah. So what happened if you close the switch? Yeah, if you close the switch, then here got current flow. Here got current I1. Here got current flow I1. It go through here. When you got current, then the VAC, will be less than EMF. Yeah. If you got current, then what happened, class? If you got current, when you close, then you get this one. So you get VAC less than E1, less than EMF. Yeah, because when you close the current, got current, the VAB less than EMF. Yeah, like this case, the VAC over here you get less than E1. Because why? Because VAC now is equal to E1 minus IR. Because got drop in internal resistance. This is called the terminal voltage. The terminal voltage. So E minus IR. And then we somehow we can say is also equal to VAC now is also equal to IR besar. Ya. IR besar. That means the voltage here, see the voltage here is equal to voltage here and also or voltage here. Voltage here also or voltage here. Along here is E minus IR. Yeah, along here is IR besar. Understand? IR besar. Yeah, IR besar. So itulah. This is all the terminal voltage lah. You get less than EMF. Yeah, E minus IR. So about this one, I will discuss in future lah. Yeah, I will discuss in future. So okay, if we discuss the question tutorial. Yeah, because now not much enough time. Already past already time. Okay, so thank you so much, class. That's all for today.
Thank you, sir.
Okay, thank you.
Thank you, sir.
Okay.
Thank you, sir. Thank you, sir.
Yeah.
Thank you, sir.
Thank you.
Thank you, sir.
Okay, thank you.